So my dear children, in the earlier chapter we discussed the basic things related with the force, like the introduction part, what do you mean by pushers and pulls. Then after that we discussed how to measure a force and what do you mean by the magnitude of a force. So those are the basic things that we discussed under the force, introduction to force, and about the magnitude of the force lesson parts, right? So within this chapter we'll be discussing another special characteristic feature that can be identified within the forces, right? So here we are going to discuss mainly about the direction of the force and the point of application of the force. Direction and the point of application of the forces. These are the two main parts that we are going to study within these two lesson part, within this lesson part. So let's see what do you mean by this point of application thing and what is the direction of the force thing. So here, when a ball is being hit, the direction of the ball decides the direction of its motion. When a drawer is being opened, it should be pulled towards us. Let's imagine that you need to open a door by applying 5 Newton of a force. Okay, let's imagine that you need to apply a force of 5 Newton to open a certain door. Let's take the same drawer which is going to open in here, given the text under the first point, right? So to open that drawer, you have to apply 5 Newton of a force. You have to apply 5 Newton of a force. Okay. You know that the force is being measured from newtons, right? Force is being measured from newtons. Newtons is the unit that we use to measure the force. So 5 Newton of a force should be applied to open a certain door or else a drawer. Now I'm coming towards you and I'm going to tell you guys, open the drawer by applying 5 Newton of a force. You might get confused. Why is that? Why is that? Because you don't know whether the door is getting opened by applying a push or else a pull, right? You don't know whether it is applying by a push or whether it is opening by a push or whether it is opening by a pull. You don't know. If it is not being printed on the drawer or on the door, so that pull or push, then you don't know. Definitely you don't know at all. So my dear children, in here, no matter the pushers or pulls which been applied at that instance, right, there should be a direction. There should be a certain direction to apply a certain force. The drawer cannot be opened by applying a push. Here it is strictly saying that you have to pull towards us. So if it is being asked to pull, you can't do the same work. You can't do the same work by applying a push on it. Why is that? What is the reason for it? Why we can't apply a push if it is saying to pull? Why we can't apply a pull if it is saying to push? What is the reason for it? You know that both the pushers and pulls are considered as forces, right? So by applying 5 Newton of a pusher or a pull, we should be able to open the drawer. But however, it's going to work only with the pull, not with the push. The reason is pushers and pulls, I told you, my dear children, they have a definite direction of action. They have a definite direction of action. There's an acting direction for a push. There's an acting direction for a pull. Right? You can't do the same work by pushers and pulls, right? The same effect given by a push will not be given by a pull, right? Same effect given by a pull will not be given by a push. In the same way, same effect given by a push will not be given by a pull. Pushers and pulls are acting in opposite directions. So direction, my dear children, direction is a very important characteristic factor that can be observed within the forces, right? Direction of the force. So here, when it is to be closed, it should be pushed to the opposite direction. Thus, it is clear that not only the magnitude but also the direction of application of force is important. So, like I said, apply 5 Newton and open the door. You may get confused. Why? You don't know the direction of opening the door. Whether the door is getting opened by a push or whether it is by using a pull. You don't know the certain direction. So, in that case, you might get confused. So, my dear children, when applying a certain force, not only the magnitude, but also we have to consider the direction as well. Right? So, direction of the force which is applied is also another characteristic feature that we can observe within the forces, the direction. Right. So, here given, apart from this, the result of a force changes according to the point on which it is applied. For an example, consider a bottle placed on a table. If it is pushed with the finger kept close to the bottom, it will move away along the table top. But if it is pushed at the top, it might topple. Right. A bottle is placed here. From the midpoint, you are applying a force, right? Not actually at the very midpoint, but somewhat closer to the bottom. Bottom means to the tabletop. You are applying a force by using your finger. In this case, what will happen? Right? In this case, you can clearly observe that the bottle is going to move to a certain direction, right? Which the direction is away from your finger. Okay. Now, in this case, the object will move for sure. But however, if you change the point of application of the force, what do you mean by the point of application of force? Is the place that you are going to apply the force, right? Simple. Now, in the earlier case, you applied the force to this position. Now, we are going to apply the force like to somewhat up, to upper position, to an upper place, like this. I'm going to apply force. Now, in this case, my dear children, there is a possibility. In this case, there is a possibility that the object or the bottle in here may topple and might fall down. If you apply a certain force which is enough to to move the object, definitely the object or the bottle in here will fall down. In the earlier case, it moved. In the second case, it's going to topple and fall down. So, my dear children, not only the magnitude, not only the direction, but the point of application of the force is also really important when you are doing any kind of a work, right? When you are doing works by applying forces, it's important to consider all these three facts. What are these three facts? Number one, the magnitude of the force that you are going to apply. If you apply certain like higher forces, you won't be able to do the you won't be able to get the necessary effect from the force, like that throwing basket thing. Can you remember? If you are going to push the ball which that has a very high amount of a force, then you won't be able to make the basket. If you are applying lesser force, then also you won't be able to make the basket. You have to apply the proper amount of force to have a basket only. Okay, magnitude. Second one is the direction of the force, like opening and closing a drawer or else a door. If let's imagine that to open a door you need to apply 5 Newton, but however you need to know to which direction that you need to apply this 5 Newton of a force, towards you or away from you, push or a pull, like that you should know the direction which the force should be applied in order to open the drawer. Okay, in order to open the drawer. Second case, the direction of the force. And the third one, now the drawer is like this. I'm going to take this one somewhat up. So this is the door, right? You know that there are hinges fixed to the door like this. These are the hinges. This is the door lock or the handle of the door. Now usually to open the door, right, let's imagine that you have to move to that direction to open the door. So normally you are applying a force on the handle and you are applying that force to that direction. So the door will rotate and travel to that direction like this. But however, by applying a force like in this kind of a position also, like this kind of a point also, you can move the door. You can move the door like this. But however, the thing is that it's really difficult. It's very difficult to move the door if it is closer to the rotation point. If it is closer to the rotation point or to the rotational axis, this is the rotational axis now. This is the axis or the line. Along this line which I am going to draw in here, along this line the door is getting rotated to here and there. So if the point of application of force is very near to the if it is near to the rotational axis, then my dear children, you can't move this door quite easily. That's why always the handles are like somewhat far away from the rotational axis, right? So the point of application of the force is also going to matter. Even though, now let's imagine that 5 Newton force should be applied to open this door and you have to apply to that direction. If I'm here like this, then I need to push it like this. Okay, I need to push it. Okay, you need to push like this to open the door. So you know the direction, that is the direction, you know the magnitude, this is the magnitude. However, if you apply on the handle, if you apply this force on the handle, that means on A, in that case only you can move the door by applying this much of a force. If you are going to change the point of application, then my dear children, you won't be able to open the door by applying this amount of a force. It's because now you are changing the point of application of the force. Usually you have to apply forces on the handle of the door, right? If you are changing the point of application, then you won't be able to do the same effect by the same magnitude of the force. So the third most important factor related to the forces is the point of application. Point of application is really important, like in these cases, right? Point of application is really important. It would make our work easy. It would make our work very easy. Point of application of the forces. So, I'm going to erase these things now. And once again come to my lesson part over here, right? So here you can see that the point of application is also really important in application of forces. Now if you want to move this bottle toward a certain direction, you should apply the force like in this kind of a position, otherwise it will definitely fall down. Like if you apply a force in here, then definitely it will fall down, right? So these are the three main important facts that you need to consider about the force. One factor we already discussed, that's the magnitude. Now we are going to discuss about the direction and the point of application. So I have given you a brief about the direction and the point of application, right? So my dear children, the point of application of force. So point of application means what? It's the place or the point that we are going to apply force on a certain object. The point or the place where the force is applied on a certain object is called the point of application. Really simple, right? So we'll write down the point of application thing then. Point or the place where the force is applied. Point, place where the force is applied on point or the place where the force is applied on the object. On an object. Is called the point of application. Right, is called the point of application. So point or the place where the force is applied on an object is called the point of application. So point of application means, my dear children, it's the place or the point which the force is being applied on a certain object, right? The point or the place which force is being applied on a certain object is called the point of application. This is the one which is referred as the point of application, right? Point of application. The point or the place where the force is applied on an object is called the point of application. Really simple, right? So if I'm going to apply a force like this on this point, so this is the point of application. Let's say 5 Newton of a force is being applied in here. So this is a point, is the point of application. Right, point of application. This is the point of application, the A point. the amount or the magnitude of the force which applied is 5 Newton. The direction is like this, right? All three factors are there now. Point of application A, direction that way 5 Newton, magnitude, right? So this is the point of application, right? So studying about the direction of force, now we are going to study about the direction of the force. We're going to study about the direction of the force quite further. To identify the direction or to study about the direction about the force, we'll be needing these materials. So we are doing a small bit of an activity. So these are the materials that you need. Wood block, some nails, right? Nails, then thread, right? So these are the materials. Quite simple bit of an experiment. Okay, activity. You'll be needing a wood block, nails, and some pieces of threads, right? So let's see how to conduct the activity then. Right, now let's see how to conduct the experiment, my dear children. So here the method is given, fix a nails. Now here there is a mistake in your textbook. It should be fix a nail, right? So here I'm going to erase that thing. So fix a nail. So fix a nail at the midpoint on one side of the wooden block, right? So in your textbook there is a mistake in the method, right? It should be nail, not nails. So fix a nail at the midpoint on one side of the wooden block. Tie a piece of thread to the nail so that the thread is, now here also you can observe another mistake. It should be leaning. So that the thread is leaning on the block. So we have to insert the iron nail so that the thread is leaning, okay, leaning on the block, right? It should lean on the block. Thread should lean on the block, okay? There is a mistake, my dear children. Check and recorrect it. Then place the wooden block on the table as in figure A, right? On like figure A, you have to do what? You have to place the wooden block on the table and pull it to a side by the thread, keeping the thread horizontally, right? Keeping the thread horizontally. Right, so my dear children, there is another mistake in here. Now here you can observe that the keeping the thread has been repeated once more. So I'll cut one in here. In your textbook also you can observe the same thing, right? They also have repeated the same step. So I'm not going to recorrect the things which are included in your textbook. I'm going to mention these things specially for you guys, okay? So in your textbook also, my dear children, there is a small bit of a mistake in here, right? So I have erased it right now. So place the wooden block on the table as in figure A and pull it to a side by the thread, keeping the thread, right? Keeping the thread. So here also there is another mistake, right? It should be thread. Right, keeping the thread, right? There is also another mistake saying thread, should not be thread, right? So keeping the thread horizontally. Observe the direction of motion of the wooden block. So first step, really simple. What you have to do, place the wooden block on the table as in figure A. This is figure A, right? This is the figure A. Then you have to pull it to a side by the thread. You have to pull it to a side, right? Pull it to a side by the thread, keeping the thread horizontally. Now the thing is that you have to keep the thread horizontally. It should not turn to a different location. It should keep horizontally. Okay, it should not show an angle. So in the same way, you have to you have to push it to a different location. Observe the direction of the motion of the wooden block. Then you have to observe what's going to happen in here. You have to observe the motion. Then change the direction with keeping the thread horizontally of thread as in figure B. Now by keeping the thread horizontally as like in this figure B, you have to turn it to a different location, right? And you have to once again draw. Observe the direction of motion of the wooden block. Then you have to observe the motion of the wooden block, right? So like in figure B, then you have to move to a different location, to a different position, like this, to a side. Then you have to drag it, then observe what's going to happen, right? So it's really simple. So now let's head on to the laboratory and we'll conduct this activity, and let's see the direction of motions in each of the instances. To identify the direction of the force which is going to apply on a certain object, I have with me, my dear children, a wooden block. So I have fixed a nail onto this wooden block, and once again there is a thread. Okay, now first of all we need to keep the wooden log like this. Now so I'm going to take the thread and keep it horizontal like this. Now I'm going to push it. Okay, I'm going to apply a certain force on here on the thread, and I'm going to pull it towards towards my hand, right? So let's pull it and observe what's going to happen. So as you can see here, now the thread is horizontal, okay, and I'm going to pull it. So you can see here, when I'm pulling it, the thread is at a horizontal level, right? Thread is at a horizontal level when I'm pulling it. See, once again. So when I'm pulling it, thread is at a horizontal level, and the object is also moving horizontally along the thread or along the direction of the thread. See? Okay. So from this observation, you can say that along the direction where the force is going to act, for the same direction, the object is going to move. Right. Now I'm going to keep the block in here, and I'm going to now, earlier we drag it horizontally, now I'm going to change the direction like this kind of a direction. Okay, now I'm going to turn, right? So you can clearly observe now when I'm dragging the thread, or when I'm pulling the thread, you can clearly observe the wooden block is turning towards the direction which the force is going to apply. See, it's very simple. Towards the force, the wooden block is going to turn. See, it's going towards the direction which the force is being applied. Okay, so in the earlier case, when I'm going to apply the force horizontally like this, I'm going to pull it horizontally. It's going to move horizontally. When I'm going to keep it like here and drag it like this, then it's going to it is turning, or it is going to a side, or it is traveling to the side, same side which I'm going to apply the force. Not horizontally, but it's showing some kind of an angle, right? So here you can see that according to the direction which I'm going to apply the force, right? According to the direction which I'm going to apply the force, the object is going to turn and travel, and object is going to turn and start the motion. If the force is horizontal, then the motion is also horizontal like this. Okay, horizontal motion. If the force is like leaned toward some kind of a direction, then the motion is also going to lean towards some kind of a direction, right? Okay. So my dear children, from this activity it is obvious to us that according to the direction of the force which is applied, the object is going to move. So let's head on to the classroom and we'll write down our observations from the experiment. Right, my dear children. So we conducted the activity. That was a very simple activity that you can observe, right? You did observe. Okay. So over there, when I was conducting the activity, you could see that when I'm going to push or when I'm going to move, or when I'm going to draw out that thread, you could clearly observe that the direction of the block is also going to change. It's going to change according to the direction of the thread, right? So you are given with the observations here. You could observe that the wooden block moves in the direction of the pull, as in figure A of the above activity. All right, now according to the figure A, when I'm going to drag it to the same direction, it moves. When the direction of pulling is changed as in figure B, the direction of the motion of the wooden block change as shown in figure C. So when I'm going to change the direction, like to a different location, when I'm going to take it to a different location, you can see that the direction of motion is going to change, like according to the figure C, right? According to the figure C. So here we can come into a conclusion that, okay, force acts to the direction of pulling along the thread, right? The force is exerted, or the force is going to act to the direction of pulling along the thread. Along the thread, it's going to act to the direction of pulling. So when I'm going to pull like this, it's going to move like this. When I'm going to turn and pull like this, then it's going to go like to that kind of a location. Okay, so it's quite clear to us that in here, in each of these instances, right, my dear children, along the thread, the force is going to act, and when I'm going to change the direction, the force also going to change its direction. So the object moves along the direction of the force exerted. Object is moving to the same direction as the force is getting applied. Okay, object is moving to the same direction as the force is getting applied. That's why when I'm turning, it's going to turn. When I'm going to keep it horizontally and pull, it's going to come horizontally, right? When I'm going to change the direction, it's going to change its motion direction as well, right? So this is the conclusion that we can take from the activity. So the two conclusions once again: the force act to the direction of the pulling, or the force is going to act into the direction of the push or the pull, and also according to the direction of the motion, according to the direction of the force, the motion is going to occur within the material or within the object. So these are the two basic observations and the conclusions that we can take from the activity. Right. So this is our activity, my dear children. Now let's move on to observe another special kind of an activity. Here we are going to use two blocks of wood. One is a round shaped one and the other one is like a block in here. Right. So let's see how to conduct this activity. Another activity in order to identify or the study the direction of the force applied. Okay. So here also we are going to study the direction of the force applied. So materials that you need here is very simple. Wooden block, then a wooden disc, then once again nails and thread. Right. So we'll be needing a wooden block, wooden disc, some nails and threads. These are the materials that you need in identifying or studying about the direction of the force in this case. Right. Okay. So let's see what is the method in doing the activity. So here you are given fix Tintex nails to the points A, B, C on the upper surface of the wooden block as shown in the figure. So here you can observe 3 points A, B and C in here. See, A, B and C. There are 3 points. This is A, this is B, this is B and this is C. Right, this is B and the earlier one was C. Right, the 3 points. So you have to fix 3 Tintex nails on each of these 3 points A, B and C. Now tie a piece of thread to the nail A of the wooden block and pull the thread horizontally. And now what you have to do? Tie a piece of thread to nail A. You have to tie a piece of thread on nail A of the wooden block and pull the thread horizontally. You have to pull that thread horizontally. Observe the direction of motion of the wooden block. Then you have to observe the motion of the wooden block. In the same way, tie pieces of threads, right? Tie pieces of thread to points B and C of the block. Once again to B and C of the block. And pull separately. You have to once again pull separately. You have to keep the thread horizontally and pull. Observe the direction of motion of the wooden block. Then you have to observe the motion of the wooden block. Right. Then the disc. Fix a nail to the center of the wooden disc as shown in the figure. As shown in the figure, you have to fix a nail onto the middle, onto the midpoint, onto the center of the wooden disc. Then tie a piece of thread to the nail fixed to the center of the disc. Right? Then you have to fix a thread. Pull the thread to the directions 1, 2 and 3 by keeping it horizontally as shown in the figure. Observe the motion of the disc. Then this is the iron nail. You have to pull to here you have to tie a piece of thread, then pull to number 2, pull to number 1, pull to number 3. In 3 different occasions you have to pull it and observe the motion of the wooden disc in here. Okay, in 3 different occasions to in here for the 3 different locations, for the 3 different places, like according to the figure, you have to pull the wooden disc by using the thread. Okay, then you have to observe what's going to happen, or what is, to which kind of a direction does the disc is going to move. That's it. So this is the way of doing our experiment, my dear children. It's really simple. Now here we have used 2 different objects, okay, in order to observe the direction of the motion, right? Right then, so let's head on to the laboratory once again and we'll conduct the activity, and let's see to which directions does the object is going to move in each of these cases. So my dear children, now in here, this activity, we are going to use 2 different objects. Here I have with me a wooden circular shaped wooden object, and this is a wooden block. Okay, now first of all, I have pinned 3 tinted nails on the wooden block here, and they are fixed with a piece of thread like this. So I'm going to first of all, then if you can see here, the wooden disc also is fixed to a thread like this. Now this thread is fixed to the iron nail which is on the center of the disc, and I have marked 3 directions, 1, 2 and 3 on the wooden disc. So first of all, I am going to keep this thing away and I am going to take the wooden block. Now there are 3 threads, 1, 2 and 3 along 3 different directions. Now I am going to apply certain forces on each of these 3 nails. Now I am going to pull it and drag along this tabletop and see when I am going to apply the force, what's going to happen with the direction of motion. So first of all, we'll apply the force from here, from this thread. So as you can see here, when I'm applying the force from that thread, the object is moved along the direction of the thread. Once again from this thread, I'm going to apply a force. So along the direction of that thread, okay, the object moved. Third one. So as you can see here, along the direction of the thread, the object is going to move. See? Object is going to turn to the direction of the force and then it's going to travel towards the direction of the force. It's quite simple. So here also, according to the direction of the force which is being applied, you can clearly see that the object is going to move, my dear children, right? So I have applied forces along 3 different locations. So these 3 points are the points of application of forces. So along the direction of the force which I am going to apply, right, on each of these threads, the object was moved, right? So that was our observation. Now we'll keep this wooden block in a separate place. Let's take the second object, our disc. So disc, as you can see here, this is the thread. Now I'm going to turn it towards number 1 and I'm going to pull it gently. So as you can see here, the object is now traveling towards number 1. And you can see here very clearly, right? You can see here very clearly, the thread is also directing towards number 1. Along the direction of number 1, the thread is also being kept, right? See, the object is moving towards number 1. Now I'm going to change the direction, number 3. So as you can see here, now the object is moving towards number 3 and the direction of motion is pointing, the thread is pointing towards number 3 and the direction of the motion also towards number 3. Now once again, number 2. Direction of motion is towards number 2 and the thread is also directing towards number 2. Once again, see, number 3, number 1, number 2. See, according to the direction which I am going to pull, see, according to the direction which I am going to pull the object is getting moved from this activity, right? From this activity, you can say that irrespective of the shape of the object, according to the direction which the force is being applied, the object is getting moved. And according to the same direction, right? According to the same direction, the thread is also moved. It's actually not moving, but it is directed towards the area or the place or the direction which the force is being applied. Object over here is going to move towards that direction which the force is getting applied. So here it is obvious to us that according to the direction of the force, the motion of the object can be observed irrespective of the shape of the object. Right then, so let's head on to the classroom once again and we'll write down our observations and then conclusions of the activity. Right, so it's obvious to us that, my dear children, when I was conducting the activity, you could clearly see that according to the direction of the motion, according to the direction of the force, objects are going to move, right? So it's really simple. Along the direction of the thread, forces are getting applied, and according to the direction of the force applied, objects are getting moved. Okay, so our observation was quite simple. Objects are moved according to the direction of the thread. Okay, objects are moved according to the pulling direction of the thread. If I'm going to pull the thread to my direction, then it will move to that direction. Like away from my, then going to that direction. If it is like this, coming toward this. If it is like this, then it's going like that. So according to the direction of the, according to the pulling direction of the thread, objects are moved, right? According to the direction of the pulling direction, right? According to the pulling direction of the thread, objects are moved. That was our observation, right? So we can write our observation. Objects are moved according to the pulling direction right? Objects are moved according to the pulling direction of the threads. Thread or threads. So objects are moved according to the pulling direction of the threads. So conclusion from this activity is that according to the right. So conclusion from this activity, my dear children, according to the direction of force applied objects are moved. Right? Objects are moved. In simple, you can say that objects are moved to the direction of the force. Objects are moving to the direction of the force. Objects are moving to the direction of the force applied. Right? So, to the direction of the force applied, objects are moved. So, according to the direction of force applied, objects are moved. Right? According to the direction of force applied, objects are moved. In simple sense, you can say that objects are moving to the direction of the force applied. This is our final conclusion from the activity, my dear children. Right? So, in above activity, it is observed that the objects move to the direction of the force. So, it's obvious. That's the final conclusion that we took also. Right? Objects move to the direction of the force. To the direction of the force, objects are getting moved, irrespective of the shape and the change of direction. Right? No matter the shape or no matter the change of direction, whatever the direction of the force applied, to the same direction the object is going to move. Okay. Moreover, the thread is directed to the direction of force applied through the point of tying it to the object. So, the thread which been used to tie the object. So, when I am going to push the thread or pull the thread, when I am going to pull the thread, the force is acting along the thread and it is also directed to the same direction as the motion. Here, the point that the thread is tied is the point on which the force is acting on the object. The force is acting on the point where, right, the force is acting on the point where the thread is being fixed. That point is known as the point of application of the force. So, that point is called the point of application of the force. Point of application of the force, my dear children. Right? Point of application. Okay. So, the point where the thread is being holding up is the point of application of the force. And the direction can be identified by the stretch direction of the thread. Okay. So here it's quite obvious to us that force is a certain quantity that has a magnitude, as well as it is going to show a certain direction. If you do not apply forces to that direction, then we can't do the works that we need. Like opening a door, if it is saying to push, then we have to apply a push. When closing the door, if it is saying to pull, then we have to apply a pull. So my dear children, it's important to study that. It's important to note out that forces are special kind of quantities, or those things are physical things, physical quantities that carries a certain direction as well as a magnitude, right? As well as a magnitude. So force is a special kind of a quantity that can be measured from a certain value and which shows a definite direction of application. So the physical quantities that has both of these factors, what are the two factors? Direction as well as a magnitude or else a value, are referred as vector quantities. These things are called as vector quantities. Each and every force is a vector quantity as it is showing a direction as well as a certain type of or amount of a magnitude. So here it is given, the quantities that have a magnitude as well as a direction are known as vector quantities. These are called as vector quantities. In the above activities, it is confirmed that the force has a magnitude. So we know that the force is going to have a magnitude and also a direction. So force has a magnitude and a direction. Therefore, force is a vector quantity. Very special quantity. Force is a vector quantity, my dear children. Usually, most of the times, you will be studying about, or you will come across with different types of quantities which they do not have a certain direction. They have a magnitude, however they do not have a direction. Like when you are taking account of something, number of teachers, number of students, number of particles, which is also referred as the mass, those things are referred as scalar quantities, right? Scalar quantities. In these scalar quantities, specialty here is that it's representing some amount of a value only. There's no certain direction in it. Like, can you express a direction for number of teachers? No, obviously you can't. Can you express a direction for number of particles or mass in a matter? Right? No, you can't. They are representing or reflecting a value only. Like that way, there are several scalar quantities in our day-to-day, we come across in our day-to-day life. Such examples are pressure, which we will be learning in the next lesson, pressure. Then when you are taking account of something, amount of something, definitely it's reflecting just a count only. Like the mass of a certain substance. I told you mass, by using the mass, we are measuring number of particles contained in it. So mass is a scalar quantity, mass. Then if you take the speed of a certain object, doesn't have a definite direction. It's showing a value only, speed. Right, speed. Then my dear children, distance traveled by a certain object, distance, that is also a scalar quantity. So like that way, there are several scalar quantities, but however, force is not a scalar quantity. It is showing a definite direction with a certain amount of a magnitude. So therefore, force is referred as a vector quantity. Force is a vector quantity. So weight, which is the gravitational pull acting on a certain object because of the gravitational force. Gravitational pull means a force. Definitely then weight is a vector quantity. Direction of weight is always towards the ground, towards the earth. If it is a vector quantity, then definitely it should have a direction. Okay, it should have a direction. So my dear children, vector quantities are the quantities, physical quantities that has a direction and as well as a magnitude. The opposite of this thing is called the scalar quantities. In scalar quantities, is only a magnitude, there is no certain direction in it. For vector quantities, force and weight are some examples. For scalar quantities, count of something, mass, pressure, speed, distance, these are the examples. Right then. So my dear children, now we have discussed several things related to the magnitude of a force, then about the point of application of the force, then about how to like the direction of the force, like the pushers and pulls. So we have discussed like in a vast area in how to, or what are the special characteristics of the forces, and what are the things that we apply as forces, effects of forces, and so on. So we have studied the basic features and characteristics and also the meaning of the force. Now here within this part we'll be studying how to represent a force graphically, right? How to represent a force graphically. Right, my dear children, now we are going to study about how to represent these forces by using a simple figure or by using a graphical figure. How to represent or the graphical representation of a force. Right then, the magnitude, direction, and the point of application of a force can be graphically represented by a segment of straight line. And now my dear children, by using a straight line segment, we can graphically represent the magnitude of the force, direction of the force, and the point of application. All of these facts, okay, all of these facts can be represented by using a small bit of a figure, okay, by using a straight line segment. Now here specialty is that when you are representing these are the three conditions that we need to follow in representing each of these factors. Number one, magnitude is represented by the length, right? Magnitude is being represented by using the length, means that we are drawing out a scale diagram. We are going to assume that 1 Newton is equal 1 centimeters. Like that way we are drawing it into a scale. Then 5 Newtons is equal to 5 centimeters. But like that way we are representing the magnitude of the force by using the length, of the straight line segment. Okay, by using the length of the straight line segment, we are going to show the we are going to show the magnitude of the force which is getting applied. For that thing, we are going to use a small bit of a scale diagram, okay, like by writing a relationship like 1 Newton is equal to 1 centimeter, or you can use any of a scale that you want, okay. So second point, my dear children, see, the direction is represented by the arrowhead. Direction of the force is getting represented by the arrowhead. So you know that the force is being represented by using a straight line segment. So to the direction of the force which is getting applied, we have to draw, or we have to show an arrowhead. We have to draw and show an arrowhead. So arrowhead is used to indicate the direction of the force. Okay, direction of the force is indicated by the arrowhead. Number 3, the point of application is represented by the dot at the starting point of the segment of the straight line. Now the point of application, to show the point of application, we have to insert a small bit of a dot at the position where the straight line is going to begin from the object. Forces are getting applied on certain objects now. So at the point which the straight line is going to start, right? At the point which the straight line is going to start, we have to draw and show a point. So that's the point of application of the force. So once again, the 3 cases are indicated like this. We are using the length of the straight line segment to indicate the magnitude of the force. Here we are using a small bit of a scale, right? By using the scale, we are representing the length, like 1 Newton equal 1 centimeters, 2 Newtons equal 2 centimeters. Okay, if you want, you can increase the scale as well. Like 1 centimeter is equal to 5 Newton. So in that case, if you want to indicate like 10 Newton, then you just draw 2 centimeter of a line. Okay, if 1 centimeter is equal to 5 Newton, then you just need to draw 2 centimeter of a line to indicate 10 Newton of a force. Really simple. Then the second case, the direction is represented by the arrowhead. You are using an arrowhead to represent the direction of the force. Direction of the force is mentioned by using an arrowhead. Then the point of application is represented by the dot at the starting point of the segment of the straight line. So at the starting position of the line segment, you are putting dot, right? So at that place, you can observe the object as well. So that's the place of the point of application of the force, right? That's the point of application of the force. So my dear children, these are the 3 main key components. And how to show these 3 main components in the graphical representation of a force. Right then. For example, let us consider a force of 10 Newton acting on the wooden block X. So this is wooden block X, a 10 Newton of a force. A force of 5 Newton acting on the wooden block Y. See over here, 5 Newton of a force acting on wooden block Y. Magnitude of the force 10 Newton acting on the object or the wooden block X is denoted by the length of the horizontal line. Now here you can observe the line here, it's equal to 10 Newton of a force. Let's say that this is like 5 centimeters. 5 centimeters. So 5 centimeters is now representing 10 Newton. Okay. So you can say that 1 centimeter is equal to 2 Newton of a force. You just need to divide both the sides by 5 to get the relationship. So here 1 centimeter is equal to 2 Newton in this case. So therefore, when you draw 5 centimeter of a line, I'm just imagining that this is equal to 5 centimeters. It's not the actual value. I'm just imagining that this length is 5 centimeters. Okay. So if this length is 5 centimeters, if this 5 centimeter is going to show 10 Newton of a force, then our scale is 1 centimeter is equal to 2 Newtons. 2 Newtons. Right. The magnitude of the force 10 Newton acting on the object X is denoted by the length of the horizontal line. The direction by the arrowhead. Now, this is the arrowhead direction. So, the force is acting to that direction, to my right hand side. And the point of application by the point P. Now, here you can observe the point P, the dot, right? So this is the point of application, which is point P, right? So this is the figure 1. Figure 1, you can observe these key components. Point P, the point of application, 5 centimeter of a length, that's an imaginary value. I have imagined it. Okay, I have assumed that it can be like 5 centimeters. Okay, so by that way I took an example. So I took my scale as 1 centimeter is equal to 2 newtons. Okay, this is just an assumption, my dear children. It's not the actual value, just an assumption. So length 5 centimeters. Then the direction is shown into that direction by using the arrow head. Okay, the magnitude of the force 5 Newton acting on the object Y is denoted by the length of the vertical line. Now this vertical line indicates, right? This vertical line indicates 5 Newton of a force. The length indicates the magnitude. So here, if it is drawn to the same scale as this, my dear children, okay, if it is drawn to the same scale as this, like to show 1 centimeter, like showing 2 newtons by 1 centimeter, then this whole length would be only 2.5 centimeters, right? Only 2.5 centimeters, 2.5 centimeters only, 2.5. It's because that if 10 is represented by 5, half of that value, 5 should be represented by half of the length, which is 2.5. So next point, the next point is given, the direction by an arrowhead, direction upward by an arrowhead, and the point of application by the point Q. So the point of application, this thing, by point Q. Moreover, the length of the straight line drawn to denote the force of 10 Newton on X should be twice as long as the one drawn on the drawn to denote the force of 5 Newton on Y. So I told you that here, right? Here 5, here 2.5. So you can see that exactly 2 times, right? It's exactly 2 times. This one is exactly 2 times as that value, because we are drawing it to a scale. Okay, we are drawing it to a scale. The scale is 1 centimeter represents 2 Newton. Right then. So this is the graphical representation of a force, my dear children. How to represent a force graphically. So in our day-to-day life, we apply forces on various objects. So at the beginning of the lesson, we discussed about this thing, right? We apply different forces on different objects in our day-to-day life when we are doing works. Especially each and every work that we carry out in our day-to-day life, we do by applying forces. So examples given here. When we write with a pen, we have to apply forces to move the pen on the sheet of paper. Obvious, right? We discussed this thing at the beginning of the lesson, right? So when you are writing, you are moving or you are pushing the pen and pulling the pen here and there on the sheet. So by that way you can write. Okay, by that way you can write. Second one, when walking, forces are applied on the floor by our feet. So when someone is walking, right, we apply forces on the floor by our legs, by the 2 feet of the legs, right? So by applying those forces, we are able to move here and there. Okay, we are able to move here and there by applying forces on the ground. Then, when playing cricket, forces are applied on the ball by hitting the ball. Forces are applied on the ball by hitting the bat. Right? We are hitting the ball by using the bat. Then we are applying the forces. Right? By that way, we are applying the forces. The ball is being hit by using the bat. we have to make an effort to do these types of work. Most of the time we apply forces in the easiest way to reduce the effort. Now we have to make an effort in making these things to work. I mean, like when we are doing these activities, some kind of an effort should be done, or some kind of an effort should be given in each of these instances when we are doing works. So my dear children, specialty here is that to ease the work, okay, to make it more efficient and to ease the work, we are going to apply the forces in the easiest possible way that we can. Okay, so we'll be identifying several instances where we are going to apply forces more conveniently and more efficiently and easier. Okay, right. So here you can observe two figures. Within the first figure, this person is pulling the cart or this load, but you could see that by the look of his face, you could see that he is struggling, right? It's difficult for him to push or pull this cart here and there. But in the second figure, the same person can be observed, but however, now he's happy, right? He is happy. He's easily moving the cart. Now, what's the difference in here? The difference is that, my dear children, in both the instances, the person is applying a force. But however, rather than using this position or this pose, it's easier to use that kind of a position or that kind of a pose, right? So here it is given. Consider the figure A, a person drawing a loaded cart as shown there. He applies a horizontal force because the cart should be moved horizontally, but the person has to bend and pull with a difficulty to maintain the horizontal force. So it's difficult because he has to bend and pull, right? Bending and pulling, it's very difficult, right? Your back may ache and the person also is going to have the same issue. But however, in the second figure, now he is vertically, right? In a vertical position, you can quite easily apply the force. So in the second, the difficulty can be easily overcome by drawing the cart to a direction shown in the figure B. Although the force is not applied horizontally, the cart moves to the direction we want. What we do here is change the direction of force to make the work easy. Now, in this case, you can clearly see that the force is acting like to this kind of a direction. In this way around, the angle is somewhat different, but however, the same work is being conducted. Here we are changing the direction of the force which is getting applied to make our work easy, right? So there are some certain cases in our day-to-day activities where we need to change the direction of force, right, to make our work quite easy. This is a simple example for that case. Right then. Next one. A person pushing a loaded cart is shown in the figure A. The person has to bend and push it with difficulty. To ease the work, a wooden or metal handle can be fitted to the cart, and the point where the force is applied, point of application, can be changed as in figure B. Now in the first case, the person is applying to here. The force is applied to here. You can directly see that the point of application is over here now. Now to apply the force to that kind of a place, he has to bend. It's difficult to bend and push it because there might be a case that he might fall, after traveling this thing to like somewhat different place, he might fall, right? Definitely he will fall. If there is like, like a cliff or something like that, then he will definitely fall. But in the second case, the person is using a handle and the force is not applied to here but to here. So here you can clearly see the difference between the 2 points of applications. So over there at B, the point of application is somewhat different rather than the first case. However, even though the point of application has got changed, you can clearly see that the same effect is given by the two forces. In this case also the object is moved into that direction. In this case also the object is moved into the same direction by the same person. But here with a lesser effort, here with a difficulty. So my dear children, the specialty here is that when we are doing some day-to-day works in our environment, we can change the point of application of the force, to make our work quite easy. So this is a simple example where we are going to change the point of application of force in order to make our work easy. Right then. So to make our work easy in day-to-day life, my dear children, we can change the point of application of the force on the object and also the direction of the force which is applied on the object. By using both of these cases, we can make our work easy with less effort and minimum difficulties. We can carry out the works we want. Okay, so keep these things in your mind when you are doing works in your day-to-day works in your environment. You always don't need to apply the forces onto the same direction. You always don't need to apply forces to the same point of application. You can change it according to the way you want to have the same effect, right? In a more convenient and easiest way to reduce the effort given on the work. Okay, right. So in our day-to-day life, we select the way of applying forces in such a way that the work is handled easier. What is applied here is not merely the scientific knowledge, but our practical experience also contribute a lot. But if there is some knowledge about forces, our task can be fulfilled easier. So here, my dear children, specialty is that even though you know about the forces quite well, you should have some experience in doing these things. If a person is going to move a certain thing for the very first time in his life, there can be some difficulties. However, when the person is going to move these things from time to time, I mean like when he's coming with several experience, right, then in that case he is going to know what is the best way of pushing or like moving an object to a different place. So not the scientific knowledge but the experience also is also very important when we are doing these day-to-day works, right, by using the force. However, if you know the scientific base of the forces, then it would be quite easy to apply these forces on certain objects to do our day-to-day works, right? So my dear children, we discussed several things related to the lesson part force. We identified what do you mean by a force, a push or a pull. So we discussed about what is a push and what is a pull. Then we discussed how to measure a force, right, and what is the instrument used to measure the force. Then we discussed about the point of application of the forces. then direction of the forces, then finally graphical representation of the forces, and to do our day-to-day works, we can change the direction and the point of application as we want. So now we have came to the end of our lesson. So let's see what is the summary of our lesson. So here it is given, force is a push or a pull. Force is a push, force is a pull or a push. It is a pull or a push. When force is applied, an object at rest can be moved, an object in motion can be stopped, speed of the motion can be changed, direction of motion can be changed, shape of an object can be changed, plus objects can be rotated. We studied all of these things. I have given you all of these examples. So these are the effects given out by the force, effects of force. Then standard unit of measuring force is newtons. Important, right? Newtons is the unit that we use to measure force, newtons. Newton's spring balance is used to measure the magnitude of a force. Yes, the instrument that we use to measure the force is the spring balance, Newton balance, Newton spring balance. All of these things are correct. Force has a direction and a magnitude. Therefore, force is a vector quantity. Once again, important. Force has a magnitude as well as it has a definite direction. So, forces are the things that has a magnitude plus a direction. If the force is going to have both of these things, if a quantity is going to have both of these factors, magnitude with a direction, then my dear children, this is referred as a vector quantity. So, all the forces acting in our environment, all the forces that can be observed in our earth are considered as vector quantities. Okay, vector quantities. The point on which the force is acting on the object is known as the point of application of the force. So it's simple. The point where the force is getting applied on a certain object is referred as the point of application of the force. Right? Point of application of the force. Then day-to-day life activities can be done easily by changing the direction and the point of application of a force. So by changing the direction and the point of application, we can do works in our day-to-day life quite easily with less effort and minimum difficulties. So these are the things that we discussed under the lesson force, my dear children. Right. So now with this part, I'm going to finish up with the second chapter related to the force. In the next chapter, my dear children, we'll be discussing several questions related to the force lesson. So stay with me until the end of the questions, right? So within this part, we'll be finishing our chapter. So I'll meet you again with the third chapter to discuss some questions.